this video helpful, please like, subscribe and press the bell icon for notifications. So guys, let's go in depth and have a look at standard, polar and exponential form of complex numbers in complex plane. So let's first take the standard form, and we know in standard form z is equals to a plus bi, where a is the real part of z, that is rez, and b is the imaginary part of z, that is imz. So z can be written as z is equals to rez plus imz. And in standard form, complex number can be represented in two forms. One is point form and another is line form. So in point form, we just take the real part and the imaginary part of the complex number and plot it on real and imaginary axes. And that point represents z is equals to a plus bi. And in line form, we just join this point AB to the origin to get complex number z is equals to a plus bi, and its distance from the origin is mod of z. So mod of z is the length of this line segment. Now polar form. So standard form of complex number is a plus bi, and the polar form is z is equals to r cos theta plus I sin theta, where r is the radius and theta is the angle which this line segment or this complex number makes with the real positive axis. Now if we complete one full circle and again reach to this line segment that represents a complex number, then we will make 360 plus theta angle. So this angle will be theta plus 2 pi. So 2 pi is for one complete circle and plus this angle theta. Now if we take second round, then we will make one more 360 degree. So theta will be theta plus 2 pi plus 2 pi, that is theta plus 2 times 2 pi. Now for the third circle, it will be theta plus 2 pi plus 2 pi, that will give us theta plus 3 times 2 pi. So we can say that for the nth round, we will make theta plus n times 2 pi angle. So for the nth round, angle will be theta plus n times 2 pi. So we can say that theta is equal to theta plus 2 pi is equal to theta plus 4 pi and so on. So all these angles are equal. So we can get infinite number of polar form for same complex number by taking all these values of theta and putting them in our polar form. As all of these thetas are making same angle between positive real axis and this line segment for complex number. Therefore, all possible polar form can be get by putting the value of theta for the nth round, that is theta plus n times 2 pi. So we will get z is equals to r cos theta plus 2 pi n plus I sin theta plus 2 pi n for n is equals to 0 plus minus 1 plus minus 2 plus minus 3 etc. Now the exponential form. So standard form is z is equals to a plus bi. Polar form is z is equals to r cos theta plus I sin theta. Now, by the Euler's formula, we can substitute e to the power I theta for cos theta plus I sin theta. So z will be z is equal r e to the power I theta, which is the exponential form of complex number. Now, like in polar form, we will get infinite number of exponential form of complex number. Now, if theta is the angle between the positive real axis and this line segment, and if we complete one circle and reach this line again, we make theta plus 2 pi, and for the second round we will make theta plus 4 pi. For the third round we will make theta plus 6 pi, and so on. So for the nth round we will make theta plus 2 pi n. Now all these thetas, that is theta, theta plus 2 pi, theta plus 4 pi and theta plus 6 pi, or for the nth round theta plus 2 pi n, all are equal, or they will give us the same result. So we can substitute theta as theta plus 2 pi n in our exponential form, and we will get z is equals to r e to the power I theta plus 2 pi n for n is equals to 0 plus minus 1 plus minus 2 plus minus 3 and so on, to get infinite number of polar form of same complex number. Thanks for watching.